Welcome to another episode of Alpha Audio. Next to me, Grant Samuelson from Shunyata. Well, most of my viewers and readers know Shunyata pretty well. But you have some new products that we're going to discuss. But first, I'm actually interested in a little bit of the history of Shunyata. So maybe you can summarize where Shunyata started and what their way of working is, because it's quite different from other. Well, you're not only a cable producer, but it's quite different from other producers.
Yes.
Of audio equipment.
So our CEO, designer, his name is Kalen Gabriel. Kalen is a former military scientist.
Yeah.
His job was to design and develop the military's low-level signal acquisition systems.
Yeah.
So he came up with technologies and means to eliminate distortion and noise from signals, so that they could detect very low-level signals that would normally otherwise be buried underneath the noise floor.
What I read, which I thought was very interesting, is that he also he worked on data systems, including networking technology.
So after the military, he went into working for DARPA, which is the Defense Area Research Agency, and continued his work. So he has a unique skill set at dealing with environments that have a lot of high-frequency noise that's being produced. And a lot of distortion. He found early in his research that a lot of the distortion was proximally generated, meaning that the electronic systems, in most cases, are their own worst enemy. So it's the noise produced by digital components, amplification, anywhere you have a concentration of power supplies, all feeding off a common point for electrical service.
Cross-contamination.
He calls it a component-to-component interference, or CCI.
Yeah, well, it's in line with what I hear other people say as well, is that, well, the external noise is one thing, but the internal noise of your system is another thing, and that's why I think products like this that separate each component are...
Well, that's why he went a different direction from the traditional transformer, choke, coil, regenerator. All of those things, there's nothing wrong with them, but from Kalen's point of view, they operate by blocking noise from getting into the system from outside. But by that same principle, in all the cases we're aware of, they also prevent noise from finding an exit path, the noise that's generated within the system. So it's kind of a two-way brick wall. And whereas our products, in fact, all of our products are designed to filter in two directions. Certainly anything that's coming from the grid outside, but you have to understand that noise is coming from a distance. So by the time it reaches the power supplies of your components, its intensity and the fields of radiation are quite small compared to the noise that's generated by the electronics themselves and kind of surrounding electronics like a plume of distortion, kind of like an umbrella of noise surrounding the system. And noise that's locally generated even is worse now today than it was 20 years ago.
True.
With Wi-Fi and dimmers and routers and all of the digitization of music has made it even more critical to isolate that low-level signal, which is the audio signal, from the distortion that surrounds it.
Could that be, and there's maybe a little bit of a philosophical question because there's no one answer for that, but could it be that people are now looking more and more to perfection in their hi-fi system? Because on the other hand, on the one hand, the resolution goes up because we have way better recording technology, way better amplifiers, but on the other hand, we're kind of getting detached from the music. At least that's what I notice.
Well, our goal, and this is why all of our designs are passive, because you're looking for compatibility. You want the electronic system to speak for itself and not be modulated or changed by the way that it's drawing those pulses of peak current. Now, digital electronics are a little different. They draw in a steady state.
True.
But most electronics draw very fast and off the top and bottom of the sine wave.
Yeah.
And so the base of our design pyramid is dynamic transient current delivery. That's where we spend the vast majority of our budget on designing and developing products for high-end audio and pro recording systems.
It's really hard.
Well, you have to, it's custom designed outlets, it's custom designed conductors, it's custom designed connectors. Anything you can do to mitigate or reduce inline resistance to those current impulses, because the music is tracking a dynamic signal. And so as the system is drawing the DA converters, the preamps, the amplifiers, the phonostages, as they're drawing that peak energy, anything that you put in the way of that, to our ears are a little bit more like electron microscopes for sound. So we're really not trying for perfect sound. We're trying for natural sound. We're trying for sound that you could mistake for somebody playing an acoustic guitar on the corner. That gives you your physical response to the music, and
but
it feels real.
Sounds controversial if you say we're not looking for perfect sound, we're looking for natural sound.
Yeah.
And I know where you're going, but people would say, yeah, but I just want what goes in, comes out, amplified.
Everything from our perspective starts and ends with timing and coherence in sound.
True. Yeah.
And most of the distortion that we hear in our company, Kalen, this is part of the reason Kalen and I are together, is we do listen in the same way, is around that first edge of a note, that leading edge. It's how cleanly and quickly you can get past that into the fundamental, into the second order harmonic, where the tone, the texture, the color, the weight of that note, that tells you how hard somebody's hitting a key on a piano or pressing a violin string, or how close the voice is to the microphone, that gives you that sense of reality, of naturalness, of unforced. It's all timing related. Yeah. So power, whether for better or worse, controls a lot of that because of the way that full wave bridge rectifiers interact, kind of like a high-speed typewriter. They're asking for peak current to be in front of them so they can rectify it into a steady state DC source signal, which is a lot more difficult than it sounds. And if you're holding on to current, that beginning of the note can sound a little bit slowed down, or it has like a noise associated with it that our ears immediately recognize as unnatural. So natural is just, it's hard to use words and be very specific about how what we're trying to do is get rid of that artificial beginning of the note and allow you to hear into it. Yeah.
Okay, I totally get where you're going. Like I said earlier, we're doing a lot of research on power at the moment. Well, a lot, not compared to what you do, but we're investigating the influence of power, and it's actually huge. I always say in the end, we're just modulating energy. That's what a hi-fi system does. You put in a signal and it gets amplified, and it does so with the power or current drawn from the sockets. But what strikes me is that, and I think Shunyata did a lot of research in that, is there's a lot of things we can't measure still.
Right. The vast majority, really. We're
but
just
we
grasping.
Still hear a lot of difference, and especially I think with power conditioning, there is so much going on that we don't have insight in. But how does Shunyata then still, we tested your speaker cables, for example, and it did some stuff I can't explain. And that's why I made several combinations, like, okay, is this an isolated case, or is it always the same? It seemed like it straightened the frequency response somehow. And I didn't test one of your power supplies yet. I hope we can do that. But how? There must be another way of working that you apply, because it seemed quite unique. So how do you research what you're actually creating?
Well, you look at every part of the signal path, and to put it in simplest terms, you're trying to uncomplicate the trajectory of the signal so that
Yeah.
it has fewer impedance points, fewer junction distortions, fewer less noise. You know, the type of geometry you use.
Yeah.
Metal treatments. You know, we use something called kinetic phase inversion process, which pulses energy through raw conductors. And if you have this, it's very proprietary, and it's one of those things Kalen doesn't talk about.
It even had a certificate.
But if you turn it up too much, if you over-treat the cable, you can literally melt the dielectric. So obviously, at a molecular level, he's doing something, because we've done cryogenics for years. We used to have our wire supplier pass an electromagnet over the wire while it was in its mold, in its molten state, so you could elicit a slightly smoother, cleaner signal path. The kinetic phase inversion process kind of is an amalgam or a combination of those things that does a more thorough metal conversion process, or treats the metals in such a way that you have less air gaps, less fissures, fewer anomalies in the wire that the signal has to get around. It's obviously, this is where you get into the area where the sharpshooting engineers say, "Oh, that's nonsense," and you know, but
I wasn't gonna say that, but
but we've done. I mean, that's why we do so much testing in professional recording. So, I mean, I have a relationship going back 20 years with Rick Rubin. We have a relationship going back 20 years with Astoria Studio in the UK, David Gilmour's studio.
Oh, nice.
With their top mastering recording engineer, James Guthrie, who does a lot of work outside of working with David Gilmour. But, you know, they vet our products. And these, obviously, these consumers of high-end performance systems are very specific listeners. And so, you know, we take a lot of feedback from people that really know sound intimately. Kalen looks at things very holistically. What kind of changes can he make, whether it's in a grounding system, a power distributor, or a speaker cable, that frees up the signal from the typical points of distortion that he sees as consequential. Now, whether that works or not, we let the market or the person that has the device under test make. And I think, based on the feedback and the successes we've had, whether it's in review or professional audio or medical, you know, Kalen's done a good job of making those decisions. So it's really the combination. You know, if you have your own custom designed IEC connector on the back of a power distributor, that's really getting into the weeds.
Yeah, it's just a small thing, but in the end, it all works as one signal chain.
Correct.
But, let's get to the new components. I can talk for hours about this. So
yeah, unfortunately, so can I.
I have to be careful.
Yeah, sure.
But yeah, you have a new product called the Altera, and it's a very sophisticated grounding system. I noticed there are 2 boxes, and there's a whole lot of cables that you can use.
Right.
So please enlighten me and my viewers on how this exactly works and what it should do.
Well, when and I've done I've probably, as I said earlier off camera, I've probably traveled more with Altera than any other product we've produced in the last 25 years since I started working with Kalen. And the reason is that this is a unique product that you really you can't just tell somebody about it. You want them to have the experience to fully understand the context and whether or not, or how much value this holds to an individual. So I usually just travel with one hub. You know, this is a chassis ground.
Yes, exactly. CG.
Unit.
Yeah. Okay.
Right. And this is signal ground.
Yes.
Hub. The hubs work in similar ways. They're virtually identical. The way that you connect these to components would be identical.
Oh, okay.
Ultimately, both are you're connecting to chassis ground.
Yeah.
Even if you use one of these signal adapters,
Yeah.
You know, 95% of the time, the signal connection also attaches to
ground,
chassis
yes. Yeah.
to chassis ground. This is just another tool that allows people an alternative way to make the component connection to the
because
to the
that's
unit.
quite vital. I mean, there are components with a special grounding pin on the back, like, I don't know, maybe a Moon has it as well, but my Pulse Labs has a special ground on the amp. So you would connect this to that ground pin, and that's it.
Correct. You know, there are some nuances to the way that you would make a connection, but typically, I don't have one at the table, but the most important tool to getting the most out of these products is an ohm meter, a simple ohm meter.
Yeah.
Some people use multimeters. I generally encourage people to use the simple ohm meter because sometimes multimeters can, because they measure so many different things, they can kind of not work in a linear way. The simple ohm meters, they're very inexpensive to have. They have the little needle that tells you what kind of continuity reading you're getting. If you connect one pin on the ohm meter to the ground on a component,
tap the other one,
and you take the other pin and you find a spot on the chassis, whether it's at an RCA barrel, preferably, sure, if a component has a ground post, that would be your number one connection point. The number two best connection point would be to a chassis screw, any place where you can get that spade to connect. And the reason for that is you're making a direct connection to the point on the chassis. The chassis, of course, you've got a lot of radio frequency and electromagnetic interference
get all rid of that
on it, and it filters it off. As or more importantly, when you make those connections, you know, I had a question. I was just in Portugal, and somebody asked the question, well, if you have power cords connecting to the components, what's the point? Aren't you actually causing problems?
That was my next question.
Aren't you actually causing problems by adding grounds? No, what you're really doing is, so one of the goals is to eliminate all these small micro voltage differences that exist between electronics. I mean, one of the things that causes a ground loop, which can be show up as a buzz or a hum coming from your speakers, one of the causes of that is, of course, these differences in potential to ground between electronics. Or let's say you're using a power distributor for some of your components and you're going direct to the wall with other components, and suddenly, you know, you hear a hum. And part of that is, or all of it in many cases, is because you now have these differences in potential to ground. So power cords and the ground in power cords do help. But they don't entirely balance, especially if they're not connected.
So suppose I would have one of the main causes of hum is coaxial cable in the house. At least in the Netherlands, we have coaxial cables for TV. Some have used them for internet. And as soon as you connect your television to the coax cable and then connect it to your system, you will most definitely get a hum. And you would get rid of it with one of these grounding systems. In
many cases, you would, because making independent connections to the chassis, tying it all together, and summing it through one plane, it adds to the aggregate or the total ground connections. There's better continuity between the electronics, and you're just adding the connections. You're adding better regulation of these voltage differences between electronics. And then in addition, and as importantly, each one of these ground posts on the back of the Altera units has a dedicated filter built onto the back of that ground post that is specifically tuned to eliminate or mitigate the frequencies of noise that are most commonly found on electronics.
Okay.
So
it's not a broadband filter. It's specifically
they're
tuned
specifically tuned to the frequencies that are most commonly found.
Most high frequency.
Like in the megahertz,
yes.
gigahertz.
Wi-Fi, Bluetooth.
Wi-Fi, yes. I mean, and usually once a system is turned on and running, you've got massive amounts of electromagnetic interference coming from the power supplies.
Yes.
So it does this without affecting, obviously, because it exists outside the signal path.
Yeah.
It does this without affecting at all the signal propagation.
It's not in the signal path. That's absolutely true.
Right. So we get a lot of surprised looks when I do these demonstrations, and so making that connection. If you can measure continuity from the ground pin on your power distributor or an audio component, and a chassis screw, and you make that connection either to the ground post, I no longer need to wait to hear the result, right?
Already know.
I already know what's going to happen. I can even predict just how soon somebody will come out of their chair and say, "What just did that?" This isn't like demonstrating a power cord where you have to turn off the component. You have to wait 5 minutes, if you're lucky.
But does it work? I measure gear as well, and I know how critically important grounding is when you measure your hi-fi equipment.
Yeah.
Especially single-ended stuff is very sensitive to grounding.
Correct.
Do the same rules apply to this then? Because I use balanced gear mostly for reference because I noticed it has a blacker background, and
if it's all true balanced,
of course, yes, not semi-balanced, but truly balanced gear mostly has a lower noise floor and a blacker background. Does it still work then?
Yes, absolutely.
Okay.
100%. It would. I've done all manner of systems that are balanced throughout. Single-ended phono. It is true that phono systems are more sensitive, not just to grounding issues, but also to the noise in the environment.
It's in their design.
Yeah.
It does some stuff
It's one
better,
of the first questions I ask when somebody calls me and says they've got a hum or a buzz. And like, do you use phono?
Yeah, exactly.
Is it single-ended? And then we get into we get, usually it's either grounding, but lately there's been problems with cell tower emissions and light dimming in the home.
LEDs are
LED
horrible.
lighting throws a lot of noise. So the Altera is probably, in my opinion, maybe the best tool we have in terms of mitigating noise in a way that's obvious to the listener.
Yeah.
It's not, what this does shouldn't be subtle.
Okay.
It should be easy to hear within the first 30 seconds of listening.
Really curious.
And all you have to do to A/B it is just to quickly remove, if you use bananas going into the back of each post, you just pull them all out
and then
make sure that even the post running to because your main ground should go to your power distributor. And of course our power distributors all have ground posts on them that allow you to make that main connection. So whatever your main connection is, that also needs to come out, because we've found that even having this connected to the power distributor adds to the noise floor dropping a little bit. It's noticeable.
Cool.
So it's been very effective tool for us. There are extra cables involved. It's
not cheap.
It's not cheap, and it's not for everybody.
No.
But if you have a serious investment in high performance music playback, or as in some of the studios I visit, they have, I'd say $4 or $5 million.
No, absolutely, and then it's worth the investment. But I looked a little bit into the prices, and you have a certain customer. You had a certain customer in mind, of course, when you developed this.
Actually, when Kalen designs things, the only customer he has in mind is himself. And then once
that's a way of developing equipment.
well, you know, I think it's true of, look, I think it's true of most really talented designers. They're curious about something. He has an innate curiosity.
That's a good thing.
And so he wants to satisfy his own, the questions that come up. What if I build this? How good could it be? Yeah. And when he discovered that, then you know, then we decided, well, how inexpensively can we build it, where it's as effective as it. And then, of course, right away you have.
Yeah, because I was wondering, is this system built in this, or is it different?
It's different. Okay. So that's the simple answer.
Yeah.
It's similar in the sense that it's accomplishing many of the same goals.
Yeah.
But at a price point, of course, he comes out with something that pleases him, like at the more of a reference level, and then he immediately tries to think of ways, how can I get this into less expensive products?
70%
so
of the performance.
A broader cross-section of audiophiles and music lovers can get that experience. And of course, where does this make the most sense, where people don't have to have extra boxes? It makes the most sense in a power distributor.
Yeah.
Now, because this is €3,000.
It's very interesting price point.
Yeah, he had to make some compromises. So this has, these are connected to our patented noise isolation chambers. And that have the ferroelectric substance in them that absorb noise energy and dissipate it as heat within their molecular structure.
Yes.
So it's a passive form of noise reduction, whereas this is a much more aggressive, active form of noise reduction. Yeah. But just by making these connections
you still get a common ground.
In addition to the power cord connections, further solidifies and balances those micro voltage differences on the chassis of electronics and allows them. I mean, there are companies that already understand this. I mean, MSB advocates that you connect their DACs to the amp to balance the voltage difference between the DAC and their amp. So it's not like we're playing in a field that's mystical. In fact, in the telecommunications industry, they've used grounding for years. The approach is right. The approach is kind of how much can we accomplish?
Yeah. I've seen common ground systems, and I've seen, like, it's a good example with MSB. I recently reviewed their new DAC and director. And yes, they do say that. And I know that grounding is very, very important. And it has an influence and an impact on sound quality. But I've never seen an approach like this with an extra box and cables and stuff that come with it.
Now, adding the signal ground box.
What's the difference between these two?
The only difference between them is that the signal ground box is always going to be that if you have success with the chassis ground hub, and you have a rather large system with multiple digital, switches and servers and streamers and transport, components that output a digital signal. Then the second hub can make sense by kind of firewalling those pure digital components off of your grid, your grounding grid for the main the analog signal, which include the DAC. Because the DAC outputs an analog signal.
Yeah, a lot of people don't realize
they see it as digital, but in our language, we see the DAC as an analog component. And ideally, just as in the higher end power distributors like Everest, we put independent filters on each outlet to isolate each component's footprint of noise from each other component in the system. The same is true here if you're talking about between two hubs. The second hub, let's say this made a big difference and you're very happy with it, but you have a crowded system. Let's say you have 8 or 10 components, and which usually indicates that you've got a digital system and sometimes running alongside of a phono system. And in that case, the second hub, the signal hub, the big difference is that the filters that are built onto the backs of the signal hub run a little bit higher in frequency. in terms of what the noise signatures that they're filtering.
Yeah.
So this is going to go a little bit further into the gigahertz bandwidth of noise, and which is essentially you're going to find higher order frequencies of noise riding on the chassis and the signal grounds.
Is that because of the harmonics that are being generated inside digital equipment?
Yeah, full wave bridge rectifiers, other power supply architecture.
Processors.
It's like a hammer.
Yeah.
And it's going on at the speed of a typewriter. They open and close, and when those rectifiers close, they can send off harmonics, noise harmonics that run 50 times as high as the line frequency.
Yes.
So I think a lot of people underestimate just how much signal is being lost because of the clouds of distortion that the electronics themselves generate. So this kind of furthers our passive design point of view. Because the other element that we're talking about, which includes this Gemini power distributor, is that we want this to be consistent performance across all ranges of electronics. High current, solid state, digital, analog, single-ended triode, doesn't matter. These should be sympathetic to the power supplies that are in all electronics. So instead of stuffing a box full of capacitors, let's say a component uses inductive filtering in their power supply. If you put a box full of capacitors in front of that, they're going to be at odds. And sonically, you can hear these kinds of changes. The bass gets soft, but the high frequency gets more. You're constantly. That's why for years power conditioning has this kind of hit or miss.
Absolutely true.
Good in some systems. One guy raves about it, loans it to his friend. Friend takes it home and says, "You're crazy. That was terrible." And they're both right. They're both correct.
That's the hard part.
But the one guy has, one type of electronic system, and his friend has something completely different.
True.
And so we're trying to take both with the grounding system. That's why if you read continuity, if you get continuity with that ohm and you can make a connection to that point on the chassis, I always want people to make their own discoveries, but I can tell them categorically, if you read continuity, this will work. And it's a lot less expensive than some of our very high-end power distributors.
True.
And operates on that level, though, in terms of the performance difference that you can expect to get from it. Now, obviously, it still makes the base of the system building period, from my perspective, well, okay, it's the speaker room interface is number one, and then the
Power
kind of the amp speaker interface.
I see it as a loop, actually. I mean, the amplifier is part of the signal loop in an amplifier.
Right.
So
I agree.
Yeah.
But power is right behind that because it's the origin of the signal.
I agree.
And it's that interface that can really make the critical difference between a good sounding system and something that's truly transcendent. Yeah. And the Altera adds to that more three-dimensional sound where you actually feel the weight, the body, and the true tone of an instrument. Back to that natural, if I'm listening to music, as I've gotten an opportunity to do here, and when I was in Portugal just before this, your ear, there's certain clues that you pick up. You right away I know that's a real instrument. That's not reproduced.
That's
sound.
odd, isn't it? And we never get that in even a really good hi-fi system. You still hear it's being reproduced.
I don't think there'll ever be, to use your term, perfect sound.
No,
but if you aspire to that, I think a really amazing thing. So
when I still enjoy it.
When I sit and listen, if I get the little hairs come up in the back and I get that tingly feeling of being there, that's why we spend the money we do. That's why we spend the time listening that we do. And to derive that kind of enjoyment. So, we're in pursuit of that.
Pursuit of perfection.
Pursuit, right, yeah.
There was one thing that struck me when I watched the video on your website. I think it was made by the Absolute Sound. It was a nice interview he did. And I saw that Kalin actually created a power supply or designed one that was immune to practically everything.
Yeah, he still has the patent for it's called absolute immunity power supply.
Yeah, and still he creates. But
you know that design. He also has a patent for like power factor correction, power distribution, which he's never used.
No.
And nor has he realized the potential of that absolute immunity power supply. He's still willing to talk to electronics manufacturers that might be interested in that.
It was an interesting philosophy.
It's a design exercise.
Yes.
And the design exercise informs everything else he does. And it informed what we do in the medical. In the medical field, I work in systems now that are, I mean, the noise that they produce is far more intense than anything I run into in high-end audio.
Yeah.
They have a collection of millions of dollars worth of electronics all crammed into a lab, and they're performing surgery on a patient to correct arrhythmias, looking at that very sensitive, delicate heart signal.
Yeah.
That's dictating how they're going to work around the heart to correct that rapid heart rate. So any distortion that rides that signal prevents them from really getting the successful procedure. So in that context, our products help that surgeon see that signal even more cleanly. So it really, the parallel between the medical and high-end audio is really a straight line.
Yeah, and
that's the same work.
That's the cool. Yeah, I can say that. That's the cool thing about Shunyata, I think. I mean, you work in the medical industry where they save lives.
Yeah.
And that technology is actually used in improving quality of hi-fi.
Right.
And I think there are very few
companies long before medical, we were already, I mean, David Gilmour's studio discovered us in 2003. Rick Rubin discovered us in 2004. And then more than that, they became advocates and contacted other studios and labs. And, you know, so I got the opportunity to visit a lot of my musical heroes along the way to apply the products. And what I took away from that is the consistency with which the products performed in each system. Because, you know, you can imagine when I first started, when I was called by a gentleman named David Smith from Sony Music in New York City, he was very skeptical, and he said, look, I think what you guys do is snake oil. I think that power chords don't make a difference. I think that we're wasting our time here. But I'm working with a mastering engineer named Vlad O'Meller, who's working with Rick Rubin, and they said that I needed to suspend disbelief and try your product. And of course, 3 weeks later, after we'd sent the product, I got a phone call. It was the same person, David Smith, on the line, who's now passed, sadly. And he asked he said, "Is this Grad Samuelson?" I said, "Yes." He said, "I owe you an apology." and that's really emblematic of especially back in the early 2000s when skepticism was much higher than it is now. You know, I've had to talk to engineers and convince them on just having a conversation that we're not wasting their time.
Yeah.
You know, every step of the way. Now with medical, we can really quantify third-party clinical measurements taken in comparison with products in our category that are not passive. So, you know, one of the other benefits to being passive is nothing ever goes wrong with the product.
No, true.
We have over 100 units being used in heart surgery for the last 7 years. 0 have been returned. You know, using a passive design really delivers a consistent result. It's long-lasting, generates no heat of its own, so you're not aging the parts and materials that go into the product. Between the medical and the professional, I think we've got a lot of affirmation that Kalen's design point of view is as vetted and measured and tested as anything else in our category.
I thank you for your time.
Yeah.
Because I think we're going to have a very nice demo, and I'm really curious about the effect of this one. Because I hope we can get a review sample as well, like the Gemini. I hope you enjoyed this talk about the new grounding system and the new Gemini, and let's hope we can test more of your gear.
Thank you. Thanks for taking the time.
Thank you.